Good day, students. On this clip, we're going to be going over some examples to get you ready for the trig test. So let's go ahead and take a look at question number one. We asked to find the solutions to this equation. So what we're going to do is write this equation in standard form first. So let's copy it down. X squared plus 10x equals negative 25. So to put it in standard form, you need to set it equal to 0. So add 25 to both sides. And then we'll have x squared plus 10x plus 25 equals 0. Now we can factor this using the x game. So we'll make our little x. AC goes on top, B goes on the bottom. AC is, there's a 1 here for A. So AC is 25 and B is 10. And 5 and 5 works because 5 times 5 is 25 and 5 plus 5 is 10. So we can write this as x squared plus 5x plus 5x plus 25, replacing the middle 10x with 5x plus 5x, which is the same thing. So we'll divide it down, partition it down the center factor by grouping. So we'll break it down. The first piece, we have x times x plus 5 times x plus 5 times x plus 25, kind of broken down into 5 times 5. So the first we take out x. So we have x times x plus 5. And then from the second two, we take out 5. That'll give us 5 times x plus 5. Okay? And then these two are the same. These two can be factored. X plus 5 equals 0. So we'll factor out the common terms, right? So this and this are common. So factor it out, x plus 5. And then we're left with x and plus 5. We put them together in the parentheses, equals 0. Okay? Now I can set each one to 0 and solve. X plus 5 equals 0. And x plus 5 equals 0. Subtract 5 from both sides. And then you get x equals negative 5 for the first one. And this is subtract 5. And you have x equals negative 5. So our answer is option letter B. All right. For this one, we're supposed to find f of g of x. This is a composition problem. So if we were finding f of g of x, this is a parent, the one on the outside, and g of x is the input function. Okay? So let's write down the parent function first. F of x is x squared plus 1. So the parent is going to get an input, so let's get it prepped. So we replace the x with parentheses equals parentheses square plus 1. So the name of the input function is g of x, and the value is negative 2x squared. Okay. All right, so you gotta be real careful with the sign here because this square goes to the sign, it goes to the number, and it goes to the variable. Okay. Minus times minus square is positive, 2 squared is 4, and x squared is x to the 4th plus 1. So we have 4x to the 4th plus 1. Answer is C. All right, moving along. Number 3 says what's the distance from point A to B. So what we can do here is we can make a right triangle and then use Pythagorean theorem. Okay, so if we have a right triangle like this, and then use the Pythagorean theorem. Okay, we're looking for this distance right here. Let's call this distance x. Okay, so how long is this distance? 1, 2, 3, 4. Let's call this side A. It's 4 units long, and then this one 1, 2, 3, 4. It's 4 units long. Also, okay. So let's see. All right, we'll call this B. So, and then this is C, right? So we're going to use A squared plus B squared plus C squared to find out what C is. So we're going to use 4 squared plus 4 squared. C is equals x squared. Okay? 4 squared is 16. 4 squared is 16 equals x squared. So let's switch it around. X squared equals 32. You can both sides. x equals the square root of 32, your answer is B. Alright? Okay, number 4, it says find the inverse of the given relation. To find the inverse, we just switch x and y's, right? Switch x and y's, x for y, y for x. So 1, 3 becomes 3, 1. Switch it around. 6, 8 becomes negative 8, 6. 2, 7 becomes negative 7, 2. 12, 15 becomes negative 15, 12. Alright, so which one matches this option? This one is wrong because the 12 is negated, which makes it wrong. So the 1 negative wrong because of this. 6 here is negative. 3, 1, negative 8, 6, negative 7, 2. Bam, answer is option C. Alright, 15 says which of the following cannot be lengths of a 30, 60, 90 triangle? We know the lengths of a 30, 60, 90 triangle are 1 with 3 or 2. Let's look at rewrite it as 1, 2, and 1 root 3. Okay? So all these ones right here, if I divide them by the leading number, if I can get this ratio, then that's the answer, right? So let's start with option A, 13, 26, and 26 root 3. Okay? In order to make this one 1, I have to divide it by 13. So divide it by 13, divide it by 13, divide it by 13. So what do I get? That becomes 13 divided by 13 is 1. 26 divided by 13 is 2. 26 divided by 13 is 2 root 3. Is this the same as this right here? Is it the same as this? Absolutely not. There's a 2 here, so this option is wrong. Option A is wrong. So let's try option B. We have 20, 40, 20 root 3. If I want to make this the same as that, I have to divide everything by the leading coefficient, which is 20. So I'll divide by 20, 20, 20. Okay. All right. So 20 divided by 20 is 1. 40 divided by 20 is 2. 20 divided by 20 is 1 root 3. This matches exactly with that. So our answer is option letter B. Okay. All right. Let's move on. Wait a minute. Actually, in this case, we're asked for the ones that cannot be out. So cannot. So this one is good. Since this one is bad, I'm sorry, the answer should be option A, because it says which one cannot be. Because this is the wrong one. So that's the option right there. Okay. If you take a look at C, let's just show that C is good also. For option C, we have 23, 46, and 23 root 3. To make this to see if it matches this standard notation right here, divide everything by 23, which is the first number. And then we have 23 over 23 is 1, 46 over 23 is 2, 20 over 23 is just root 3. You see it matches that, so 8. C is good also. All right. And then for number D, you just multiply by 11 over 15. 11 over 15 everything, and you end up with the same ratio as this. Okay. So the answer is option A because it doesn't work. Number 6, we're supposed to multiply this out. So let's write it down. We have x squared plus 3x over x plus 6 times x squared minus 36 over x squared minus 3x minus 18. So we're going to start with the left numerator. The left numerator is x squared plus 3x. So let's break that down. We have x times x plus 3 times x. We can factor out an x. Take out an x. We're left with x plus 3. So that's the factor form of the left numerator. So x times x plus 3. This cannot be factored any further, so we'll leave it alone as x plus 6. Now let's shift our attention to the right numerator. Okay? So the right numerator All right, numerator is x squared minus 36. So we're going to use the difference of squares formula here. You read the first and the last, plus or minus. So you're going to have x minus 6 times x plus 6. And that's the factored form for this. So we're going to have x plus 6 times x minus 6. All right, last but not the least is the denominator on the right. So the right denominator. All right, so right denominator. Our denominator, we have x squared minus 3x minus 18. We're going to use the x gain for this. Make your x. AC is negative 18. B is negative 3. So what works here is a variation of 6 and 3. So we'll make negative 6 and 3 right there. So we're going to have x squared minus 6x plus 3x minus 18. Break it down the center and factor by grouping. So we're going to have x times x minus 2 times 3 times x plus 3 times x minus 2 times 3 times 3. Okay? Take out an x from the first two, x times x minus 6. Let's take out a 3 from the last two, 3 times x minus 6. And then it's going to become x minus 6 times x plus 3. Okay? So put that in here, we have x minus 6 times x plus 3. Let's see what reduces. X plus 3 divide out. X minus 6. X minus 6 divides out. And x plus 6 divides out. And your final answer is x. So the answer is option letter A. So this is the answer right here. Okay. Number 7, which of them is equal to this? Well, if you notice, this is going to be an ellipse. We have x squared plus 4x plus 4y squared equals 324. So what I'm going to do is I cannot have any coefficient in front of any of my variables, so I'll divide everything by 4. Okay. I'm sorry, divide everything by 324 because this has to be equal to 1. So divide this by 324. Divide this by 324. And then divide this by 324. Okay. So that's going to give us the following. All right, so we're going to have x, change that color. We're going to have x squared over 324 plus y squared. If I divide 324 by 4, I'll have 81 equals 1. Okay. Now, what we don't actually need to graph this all the way. We just need to look at what we have. Since we have two squares and a plus, we have it's going to be an ellipse. So it cannot be B or C. These are hyperbolas because these ones have minuses. Okay. If you notice, we're going to go side to side, a bigger number, and we're going to go up and down. Because up and down, we're going to go with 81, which is 9 up and down. And we're going to go, because remember, your y-axis is up and down. And then root 324 is 18, side to side, because that's on the x-axis. So whichever one goes bigger, that's the right one. So you notice in option A, we're going bigger side to side than we are up and down. So the answer to 7 is A, because you have a bigger number in the x direction. So we're going to go bigger in the x direction. Okay? All right. Question 8, what's the approximate value of theta? We're going to use right triangle trig here. So this is the angle. This is my opposite. This is my hypotenuse because it's opposite 90 degrees. This is adjacent right here. I don't need it. I don't know it, so I can scratch it. All we care about is O and H. Okay? So in SOHCAHTOA, which one has O and H? Sine, right? So sine theta equals opposite over hypotenuse. Now that I get theta by itself, to do that, we'll take the inverse sine of both sides. So inverse sine of sine theta equals the inverse sine of 5 over 3, 5 over 13. Okay? and that's going to yield beta equals the inverse sine of 513. So we just plug that into our calculators and see what we get, okay? All right, so you just plug that in your calculator, inverse sine of 513, you get 22.6. So beta is 22.6 degrees. All right, so the answer is option B. All right, number 9 says what's the solution to this equation? So we have 12x equals negative 4x squared plus 5. So we'll put this in standard form, set equal to 0. Okay, so we're going to have to subtract 12x from both sides. So it's going to be negative 4x squared minus 12x plus 5 equals 0. So obviously we have to use the quadratic formula here because we have radicals. That means this cannot be factored using the AC method. So let's write down the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac, the whole thing divided by 2a. So a is negative 4, b is negative 12, and c is 5. Okay? All right, so we're going to plug all this in, and that's going to give me x equals negative 12 plus or minus the square root of 144, which is 12 squared, minus 4 times AC, negative 4 times 5. Okay? And this whole thing divided by 2a, a is negative 4. All right, so this is going to become 12 plus or minus the square root of 144. Minus times minus is a plus, and this is 80, because 4 times 5 is 20 times 4 is 80 divided by negative 8. Simplify further, we'll get 12 plus or minus the square root of 4, 624 over negative 8. Okay? All right, now we're going to try and break 224 down as much as we can. Let's do that on the side here. So we'll have a square of 224. So this is even. You take out a 2, you're left with 112. Take out another 2, you're left with 56. Take out a 2, you're left with 28. Take out a 2, you're left with 14. 14. Try that again. 28. Take out 2, you're left with 14. Take out a 2, you're left with 7. Okay? So these two 2's break out as a 2. These two 2's break out as a 2. And you're left with 14. So 224 becomes 2 times 2, which is 4 over 14. So this problem becomes 12 plus or minus 4 root 14. Let's break down the denominator over negative 8. And this one also over negative 8. Okay? All right, so now this can be broken down further into, let's see how this is expressed here. Okay, it wasn't broken down. Okay, let's put it back together. So we can write it as 12 plus or minus 4 with 14 over negative 8. So what we're going to do here was we're going to divide everything by negative 4. Okay, so divide, because there's a 4 here, divide this by negative 4. I chose to divide by negative because I have a negative downstairs here, so that moves it upstairs. So I'm going to have 3. It's going to be negative 3 plus or minus. I divide this 4 by that 4. It's going to be 1 root 14 over, divide this by negative 4 over 2. Okay, so our answers are negative 3 minus root 14 over 2, and 3 plus root 14 over 2. So our answer is going to be option letter A. All right, let's move along to question 10. Here to solve this using the quadratic formula again, because you notice there are radicals here. So let's write down the equation. 4y squared plus 4y plus 6 equals 0. Since they're all even, I can divide everything by 2, right? So divide it by 2, divide that by 2, and divide that by 2, and that by 2 also. So we're going to have 2y squared plus 2y plus 3 equals 0. Okay? All right, using the quadratic formula, let's find A, B, C. A is 2, B is 2, and C is 3. We're going to have x equals negative b plus or minus the square root of b squared, which is 4, minus 4ac over 2a. Okay? All right, so that becomes negative 2 plus or minus the square root of 4 minus 8 times 3 is 24 divided by 4. Okay? All right, now this becomes negative 2 plus or minus square root of negative 20 over 4. Okay? So let's break down the square root of negative 20. I have a negative, that negative comes out as an I. Okay? Negative comes out as square root as an I. Take out 2, 2 times 10, 2 times 5. So negative 20, these two 2's break out as a 2. Negative 20 reduces into I, 2I root 5. Okay? This 2 comes out as a 2, and then this negative comes out as an I and root 5. So this becomes negative 2 plus or minus 2I root 5. Okay? Now these options are broken up, so I can break it up to make it over 4, make that over 4. So we're going to reduce this. If I reduce this by dividing by 2, I'll have negative 1 half. And then plus or minus, divide this top and bottom by 2, I root 5 over 2. Okay? So negative 1 half and I root 5 over 2. So the answer to number 10 is option letter D. All right, so moving along, it says find x. This is a right triangle trig problem. This is my reference angle, so this side right here is going to be my opposite. Okay, this is opposite, and this is my hypotenuse because it's opposite my 90-degree angle. All right, so which trig ratio are we using? We're going to use right, sine. So sine 32 is equal to opposite over hypotenuse. Okay, to get x by itself, you multiply both sides by 17. And then you get x equals 17 sine 32. Okay? And you just plug that into your calculator. See what we get here. So 17, it does it differently. I'm going to do sine 32. The 32 sine multiplied by 17. And the answer is 9.01. All right? So 9.01 is the answer, which is option D. All right, number 12 says determine which pair of functions are inverse functions. So for number 1, we have f of x equals 12x plus 1, of x plus 1 over 6, and f of x equals x minus 9. So are these two inverses of each other? That's the question. So to do this, all I can do is let's go ahead and find the inverse of this one right here. So I'm going to go y equals 12x plus 1 over 6. So switch the x's and the y. So we have x equals 12y plus 1 over 6. So multiply both sides by 6. So we'll have 6x equals 12y plus 1. Now we're going to subtract 1 and divide by 12. So subtract 1. 6x minus 1 equals 12y. Divide by 12. and I'll get the inverse. Y equals 6x minus 1 over 12. Is that the same as this right here? Absolutely not. So 1 is not an inverse. These two are not inverses. Okay. So, these two are not inverses because we need 6x minus 1 over 12. Okay. All right, let's take a look at option 2 and see if this is an inverse of that. So for option 2, we have f of x equals x minus 9. So we have f of x equals x minus 9. Replace that with y equals x minus 9. So we're going to switch, x equals y minus 9. Now, so for y, add 9 to both sides, and you have y equals x plus 9. That's exactly what this is. So for option 2, these two are inverses, okay? And the answer is option D. All right. On 13, you asked to solve for x. This is a right triangle trig problem. So this is the angle. That means the side right here is your opposite. And opposite the 90-degree is your hypotenuse. Okay, adjacent doesn't count here. So we're going to use sine x equals opposite of a hypotenuse, 8 over 17. So we get sine by itself, x by itself, you take the inverse sine of both sides. On the left side, and then on the right side, you take the inverse sine. These two cancel out. So you're going to have x equals the inverse sine of 8 over 17. And then if you plug that in your calculator, you get is approximately 28 degrees to the nearest degree. Okay? All right. Take a look at this one. So we're supposed to divide here. So we have x squared plus 10x plus 21 over x squared minus 9 divided by x plus 7 over x minus 7. Now, anytime you're dividing, you multiply this by the reciprocal of that. So we have x squared plus 10x plus 21 over x squared minus 9 times, you reciprocate this, x minus 7 over x plus 7. Okay? All right, so for this one, you need to factor the top left and the top right and the bottom left. So let's call it the top, no, let's call it the right numerator. Okay? So right numerator, right numerator. Actually, it's on the left. So left numerator. Okay, so if we want to factor out the left numerator, we're going to have x squared plus 10x plus 21. We'll make our little x. AC is 21, B is 10. 7 and 3 works perfectly here. 7 plus 3 is 10. 7 times 3 is 21. So we have x squared plus 7x plus 3x plus 21. Break it down to standard factor by grouping. Then I have x times x plus 7 times x plus 3 times x plus 7 times 3. So we'll take out the x's. You have x times x plus 7. And this one, take out 3. There's 3 times x plus 7. So this problem now becomes x plus 7. X plus 7 times x plus 3. All right, so that goes in the top left numerator. X plus 7 times x plus 3. And our left denominator, we have x squared minus 9. So you read the first and the second, and then plus or minus the square root. So this is going to become x plus 3 times x minus 3. So here we're going to have x plus 3 times x minus 3 times x minus 7 over x plus 7. All right, so let's see what this reduces into. Please divide out. and the x plus 7 divides out, so you're left with x minus 7 over x minus 3. Okay, so the answer to option 14 is A. Okay, the answer is A. All right, moving along. Number 15 says use a diagram to find sine x as a fraction in simplest form. So I want to find what sine x is. So for sine, we know this is the angle, so this is going to be opposite. And this is going to be a hypotenuse because it's opposite the 90-degree angle. So sine x is opposite of a hypotenuse from SOHCAHTOA. So sine x is going to be opposite, which is 6 over hypotenuse, which is 10. So we can divide top and bottom by 2. So sine x equals 3 over 5. So the answer is option letter B. All right, moving along to question 16. Supposed to subtract these 2, so we have 2 over x minus 5 minus 7 over x plus 3. Okay, now we need to find an LCD. So to do that, we multiply this by x minus 5 top and bottom. Because that's x minus 5 here, and x plus 3 top and bottom here. All right, so multiply the top. We have 2x plus 6 over x plus 3, x minus 5, then minus 7x minus 35 over x plus 3, x minus 5. All right, now we're going to combine it. So we're going to have 2x plus 6. Distribute this minus to both of them, minus 7x plus 35 over x plus 3 times x minus 5. Notice how this minus changed to a plus because when you multiply minus and a minus, it becomes a plus, okay? All right, so we combine like terms, the 7x and the 2x becomes negative 5x. And then the 6 and the 35 becomes positive 41. Okay? So we're going to have negative 5x plus 41 over x plus 3 times x minus 5. And the answer is A. All right. Let's look at question number 17. We're going to solve for x. This has a 5 and a 5 or 2, so this looks like a 45, 45, 90 triangle. So this 45, 45, 90 triangle, we can put this is going to be 45, and this is going to be 45. And then let's draw our 45, 45, 90 triangle for reference. So, our 45, 45, 90 triangle is as follows. You have 1, 1, and then root 2. Okay? And this is 45, and that's also 45. This is 90. Now, opposite the 45, have a 1 here. So put this over 1. And opposite the 45, you have a 1. Put that over 1. So I can solve by using these two. So I'm going to use x over 1 equals 5 over 1. And then you just simply have x equals 5. All right? So there goes the answer. X equals 5. Answer is option C. Another way you can do this is by using the Pythagorean Theorem. A squared plus b squared equals c squared. That also works, but it takes a little bit longer. All right? But this is the quickest way. Okay. Question 18. We have to find the inverse of y equals 6x minus 2. So I'm going to switch the x out of y. X equals 6y minus 2. Well, let's get y by itself. You add 2 to both sides. X plus 2 equals 6y. And divide both sides by 6. So you're going to have y equals x plus 2 over 6. So the final answer for number 18 is D. Okay? All right. Now moving along, number 19, we have a TV of this nature. And it says computer monitor measurements are typically classified by length of the diagonal of the viewable area. What is the measurement of a monitor that has a rectangular viewable area of 12 inches by 10 inches. So let's say we have a rectangle, a monitor with these dimensions 10 and 12. So it's 12 and 10. So they asked to find the length of the diagonal, which is the dimension of the TV. All right, so we need to find that. Let's call that x. Okay. So this is 10 and this is 12. So we need to find what x is. So we just simply use the Pythagorean theorem here. This is A, this is B, and this is C. Remember, C is always the longest side and the legs are A and B. C is always opposite the 90-degree angle. Okay. All right, so we have a squared plus b squared equals c squared. That's my Pythagorean theorem. Now we're going to put these into this equation. So that's going to give me 10 squared plus 12 squared equals c squared. 10 squared is 100 plus 12 squared is 144 equals c squared. If you add these two together, you get 244 equals c squared. So c is the square root of 244. So you can plug that in your calculator. Let's do that. 244 square root is 15.6. All right, so our answer is 15.6, and that's option letter B. All right, moving along. Is rather than walk on the sidewalk, a student on her way to school cuts across a vacant lot, as shown below. What's it mean best characterizes the difference between the lengths of the two paths? So let's figure out what the length of this shortcut is. So we have a right triangle. So let's create a right triangle for ourselves and figure out how long the shortcut is, and then we can answer the question. Okay. So how do we figure out the length of a shortcut? We need to use the Pythagorean theorem. This is my C because it's opposite to 90 degrees. Okay. So we're going to use a squared plus b squared equals c squared. This is A, or this is, and this is B. It doesn't really matter what you call A or B, but this is always C. We're going to have 12 squared plus 16 squared equals C squared. 12 squared is 144. And let's do 16 squared, 256. So 144 plus 256 equals C squared. So C squared, we're going to add 144 and 256. We get 400. So C squared equals 400. C is going to be the square root of 400, which is basically equal to 20. Okay. All right. So this is going to be 20 feet. All right. Now, so it says the sidewalk path is shorter than the path across the vacant lot. So let's add these two. 12 plus 12 plus 16. If I wanted to go along the sidewalk, I'm going to have to add these two together. 12 plus 16, which is 28. That's false. It's longer. The path across the vacant lot is longer than the sidewalk path. That's a lie because the across the vacant lot is 20. Is shorter. So that's wrong. The path across the vacant lot is shorter than the sidewalk path. So the answer to number 20 is C, because the shortcut obviously shorter is 20 feet and this way is 28. All right. All right. Now, since find the equation of the graph below, first we need to do is find the center. The center is at 1 and 2. 1 and 2. So we're gonna do the opposite. So the center is at 1 comma 2. So we'll do the opposite, x minus 1 and y minus 2 square. What goes on the bottom is the square of the movement, right? So if it goes on the x direction, I'm going 1, 2, 3, 4. So we're going to put the 4 square here, minus, and then we're going 1, 2 in the y direction, so put a 2 square here equals 1. Okay. So the answer is going to be x minus 1 square over 16 minus y minus 2 square over 4 equals 1. Okay. So the answer to number 21 is option letter A. All right, so for number 22, we're going to simplify this. So we have 7, 7a to the negative 2, b to the 8, c to the 9, over. Now, on the bottom here, we can distribute this 4 to all the powers, right? Distribute 4 to all the powers. So that basically gives you a to the negative 20, b to the negative 28, and then c to the 16. Okay. So what you're going to do is we're going to subtract powers using the quotient property of exponents. So we're going to have 7a to the negative 2 minus negative 20, b to the 8th minus negative 28, c to the 9th minus 16. So that gives me 7a to the negative 2 plus 20, b to the 8th plus 28, c 9 minus 16 is 7, actually negative 7. And then we're going to have, it's going to become 7a to the 18, b to the 36. Since this is negative, we need to reciprocate it, right? So it goes downstairs, c to the 7th power. All right, so the answer is 7, a to the 18, b to the 36. So answer to number 22 is option letter A. Okay? All right, moving along, take a look at 23. It says one equation in standard form states whether the graph is a parabola, circle, ellipse, or hyperbola. We don't actually have to do that. We can just look at this equation and tell. So we have two squares and a plus, that automatically makes it either an ellipse or a circle. So the coefficients are different, that automatically makes it an ellipse. Okay? So the answer to number 23 is C. So let's go over the rules again. If you have two squares is either going to be circle, uh, two squares and a plus. Two squares and plus. Two squares and a plus is either going to be circle, it's either going to be a circle or an ellipse. If the coefficients are equal, it's a circle. If the coefficients are different, it's an ellipse. Okay, notice the coefficient. The coefficient of x squared is 1, and the coefficient of y squared is 2. 1 is not equal to 2, so that's what makes it an ellipse. If this were 2, for example, the coefficients would be the same, that will make it a circle. Okay, so anytime you have two squares and a plus, like we do here, two squares, a square and a square, and a plus, is either going to be a circle or an ellipse. But when you look at the coefficients, that's what tells you if it's an ellipse or a circle, okay? So in this case, the coefficients are different. That's why we have an ellipse, because the coefficients are different. So the answer to this is option letter C. So we don't have to do any work for this. All right. Now, number 24, it says there are two numbers with the following. The second number is more than the first number, is 1 more than the first, and the product of the two numbers is 5 more than their sum. So let's see which one satisfies that. These are equations. So this one is 5 is 1 more than 4, which is good. 4 is 1 more than 3, good. 3 is good. So they all satisfy the initial condition. Second condition, the product of the two is 5 more than your sum. So let's try option A. The product of the two, 5 times 4, plus 5. It says the product of the two is 5 more than your sum. So we add the product of the 2 plus 5. It's the product of the 2, which is 4 times 5, is this translates into equal to your 5 more than your sum. So your sum plus 5. So 4 plus 5. Okay, your sum plus 5. So is this true or false? 5 times 4 is 20. Is 20 equal to 5 plus 9? No, that's wrong. So A doesn't work. All right, let's try B. The product of the two, 3 times 4, is 5 more than your sum, 3 plus 4. Let's see if this is true. 4 times 3. 3 times 4 is 12. Is 12 equal to 5 plus 7? Is 12 equal to 12? Yes. So this what? Answer is option letter B. Okay? have it.